Understanding the requirements for generator disconnecting means in the 1999 National Electrical Code, specifically Section 445.10, involves several considerations. While direct access to the reason for change and report on proposals documents for that specific year may be unavailable, alternative resources can aid in clarifying the intent and application of the code. Firstly, consulting with the National Fire Protection Association, the publisher of the NEC, is highly recommended. You can request a formal interpretation of Section 445.10 to obtain an authoritative clarification of the code requirement in question. Secondly, exploring articles in the NFPA journal can provide valuable commentary and insights on the NEC. For example, the article Generator Disconnecting Means may offer relevant background information on the intent behind Section 445.10. You may have to search for the specific article. Thirdly, reviewing earlier editions of the NEC can illustrate how Section 445.10 has evolved, providing clues about the inspector's interpretation and the original intent of the code. When discussing the issue with an inspector, it's important to present well-reasoned arguments based on the specific installation and the overall intent of the code. Here are some potential points to address. 1. The existing paralleling gear already incorporates circuit breakers, effectively serving as the disconnecting means for the generators. 2. Adding unit-mounted circuit breakers would be redundant, leading to unnecessary expense without significantly enhancing safety. 3. Given that the generators are located in the same room as the paralleling gear and are easily accessible, the need for additional disconnecting means directly at the generators is debatable. 4. Suggesting that a strictly literal interpretation of the code may not fully align with the intended purpose, which is to ensure a safe and effective electrical installation. Furthermore, you might anticipate and address potential concerns the inspector may have. If the inspector expresses concerns about the reliability of the paralleling gear, provide assurances that the gear has been properly designed, installed, and is being maintained according to industry standards. As an alternative to unit-mounted circuit breakers, consider offering to install a manual disconnect switch at the generators. This could provide a simpler and more cost-effective way to provide an additional disconnecting means if deemed necessary. Throughout the discussion, emphasize a commitment to meeting the core intent of the code, which is to guarantee the safety and reliability of the electrical installation, while also considering practical and cost-effective solutions. When dealing with electrical installations involving parallel generators and disconnecting means, several critical factors must be considered. Understanding these factors is essential for ensuring a safe and code-compliant system. The National Electrical Code, or NEC, provides specific guidelines and requirements for these installations. A disconnecting means is a device or group of devices used to disconnect the conductors of a circuit from their source of supply. This is crucial for safety during maintenance, repairs, or in emergency situations. For generators, the NEC, specifically Section 445.10, mandates a disconnecting means to isolate the generator from the electrical system. The primary purpose of this requirement is to ensure that the generator can be safely de-energized when needed, protecting personnel and equipment. The disconnecting means must be readily accessible and located either at the generator or within sight of the generator. This ensures that in an emergency or during maintenance, the generator can be quickly and easily disconnected from the power system. The disconnecting means must be rated appropriately for the voltage and current it is expected to handle. It must be capable of interrupting the available fault current at its terminals. The rating should be clearly marked on the device. In installations where generators are parallel, special considerations apply. Paralleling generators involves connecting two or more generators to increase the available power or to provide redundancy. When generators are parallel, the NEC requires that each generator have its own disconnecting means. This is to ensure that each generator can be isolated independently. The location of the disconnecting means for parallel generators is a critical aspect. The NEC allows for some flexibility depending on the specific installation. Generally, the disconnecting means should be located at or near each generator. However, If the generators are located in the same room or area and are under continuous supervision, the disconnecting means can be grouped together at a central location. This is often the case in industrial settings where generators are part of a larger power system. In situations where the disconnecting means are grouped together, it's essential to ensure that the location is readily accessible and clearly marked. The disconnecting means should be easily identifiable and operable. In many industrial installations, parallel generators are connected to a common bus through paralleling gear. This gear typically includes circuit breakers, protective relays, and control systems to manage the generator's operation. The circuit breakers in the paralleling gear can serve as the disconnecting means for the generators, provided that they meet certain requirements. The circuit breakers must be readily accessible and capable of being locked in the open position. This is to prevent accidental re-energization during maintenance. The breakers must also be rated for the available fault current at their location. The NEC permits the use of the circuit breakers in the paralleling gear as the disconnecting means if they comply with all applicable requirements. This can eliminate the need for additional disconnecting means at each generator, reducing cost and complexity. However, it's crucial to carefully evaluate the installation to ensure compliance. One key consideration is the distance between the generators and the paralleling gear. The NEC does not specify a precise distance, but the disconnecting means must be readily accessible. If the generators are located a significant distance from the paralleling gear, additional disconnecting means at the generators may be necessary to ensure safety. Another factor to consider is the presence of qualified personnel. If the generators are in an area where only qualified personnel have access, the requirements for accessibility may be more relaxed. Qualified personnel are trained and knowledgeable about the electrical system and the hazards involved. In some cases, an inspector may require additional disconnecting means at the generators, even if the paralleling gear has circuit breakers. This decision is often based on the inspector's interpretation of the NEC and their assessment of the specific installation. It's essential to have a clear and open discussion with the inspector to understand their concerns and to explore potential solutions. When discussing the issue with the inspector, provide detailed information about the installation. Explain the design of the paralleling gear, the ratings of the circuit breakers, and the procedures for maintenance and operation. Emphasize the safety features that are in place and how they meet the intent of the NEC. If the inspector is concerned about the reliability of the paralleling gear, provide documentation showing that the gear has been properly tested and maintained. Offer to provide additional training to personnel who operate and maintain the system. Be prepared to discuss alternative solutions. If the inspector is not satisfied with the existing disconnecting means, explore other options that can address their concerns. One option is to install a manual disconnect switch at each generator. This switch would provide a visible and readily accessible means of disconnecting the generator. Another option is to install a shunt trip on the circuit breakers and the paralleling gear. A shunt trip allows the breaker to be opened remotely, providing an additional layer of safety. When considering alternative solutions, be mindful of the cost and complexity of the installation. Choose a solution that meets the inspector's requirements while minimizing the impact on the budget and the operation of the system. In some cases, it may be helpful to obtain a formal interpretation of the NEC from the NFPA. A formal interpretation provides an official clarification of the code requirements, which can be useful in resolving disputes with inspectors. The NEC is updated every 3 years, so it's essential to stay current with the latest edition. Changes to the code can affect the requirements for generator installations. Always consult the latest edition of the NEC and any applicable local codes. When designing and installing parallel generator systems, it's important to work with qualified engineers and electricians who have experience with these types of installations. These professionals can help ensure that the system meets all applicable codes and standards and that it operates safely and reliably. The NEC provides a comprehensive framework for ensuring the safety of electrical installations, but it's not always easy to interpret and apply. By understanding the key requirements and by working collaboratively with inspectors and other professionals, it is possible to create safer and code-compliant systems that meet the needs of the application. Proper coordination and communication are essential for resolving any issues that may arise. In conclusion, addressing an inspector's concerns about disconnecting means for parallel generators under the 1999 NEC requires a multifaceted approach. Firstly, gather comprehensive information about the installed system, including detailed specifications of the paralleling gear and circuit breakers, maintenance records, and operational procedures. Secondly, prepare a clear and reasoned argument emphasizing that the existing circuit breakers in the paralleling gear adequately serve as the disconnecting means, meeting the intent of NEC Section 445.10, especially if the generators are in the same room and under continuous supervision. Thirdly, be ready to discuss alternative solutions, such as manual disconnect switches or shunt trips, to address any remaining concerns about safety and accessibility. Fourthly, maintain open and respectful communication with the inspector, demonstrating a commitment to ensuring a safe and code-compliant installation while also considering cost-effectiveness and practicality. By presenting a well-supported case and being open to collaborative problem-solving, it's possible to reach a mutually agreeable solution that satisfies both the inspector's interpretation of the code and the project's budgetary and operational constraints. Remember to document all discussions and agreements to avoid future misunderstandings. It is also important to keep in mind that interpretations of the NEC can vary and local amendments may apply, so understanding the specific requirements in the relevant jurisdiction is crucial. To further elaborate on the NEC requirements and best practices for generator installations, it's worth exploring several additional aspects. The NEC provides specific guidelines on the sizing and protection of generator conductors. Section 445.13 outlines the requirements for sizing generator conductors based on the generator's nameplate rating. The conductors must be sized to carry at least 115% of the generator's nameplate current rating. This ensures that the conductors can handle the continuous load without overheating. The NEC also requires overcurrent protection for generator conductors. Section 445.12 specifies that each generator must have overcurrent protection devices, such as circuit breakers or fuses, to protect against short circuits and overloads. The overcurrent protection devices must be rated to protect the conductors in accordance with their ampacity. In addition to conductor sizing and overcurrent protection, the NEC addresses grounding requirements for generators. Proper grounding is essential for safety as it helps to minimize the risk of electric shock and to provide a path for fault current to flow back to the source. Section 250.34 outlines the grounding requirements for generators. The generator frame must be grounded, and a grounding electrode conductor must be connected to a grounding electrode system. The size of the grounding electrode conductor depends on the size of the generator conductors. The NEC also addresses the installation of transfer switches. Transfer switches are used to switch between the normal power source and the generator power source. Section 700.5 provides requirements for transfer switches in emergency systems. The transfer switch must be rated for the available fault current and must be designed to prevent the inadvertent interconnection of the normal and generator power sources. In addition to the NEC requirements, there are other industry standards and best practices that should be considered when installing generator systems. The Institute of Electrical and Electronics Engineers, or IEE, publishes standards for generator testing, installation, and maintenance. IEE Standard 115 provides guidelines for testing synchronous machines, including generators. IEE Standard 446 recommends emergency and standby power systems for industrial and commercial applications. Regular maintenance is essential for ensuring the reliable operation of generator systems. Maintenance should include inspecting and testing the generator, the transfer switch, and the associated wiring and connections. The maintenance schedule should be based on the manufacturer's recommendations and the operating conditions. Proper ventilation is also crucial for generator installations. Generators produce heat during operation, and inadequate ventilation can lead to overheating and reduced performance. The generator room should be well ventilated to dissipate the heat and to prevent the accumulation of flammable gases. In some cases, it may be necessary to install fans or louvers to improve ventilation. Fuel storage is another important consideration for generator systems. Generators that are powered by diesel or gasoline require a fuel storage tank. The fuel storage tank must be installed in accordance with applicable codes and regulations. The tank must be properly vented and protected from leaks and spills. The NEC and other codes also address the installation of fuel lines and fittings. Noise control is often a concern for generator installations, especially in residential or commercial areas. Generators can produce significant noise levels, which can be disruptive to nearby occupants. Noise control measures can include installing sound attenuators, enclosing the generator in the soundproof enclosure, or locating the generator in an area where noise is less of a concern. Automatic start-up and shut-down features are commonly used in generator systems. These features allow the generator to start automatically when the normal power source fails and to shut down automatically when the normal power source is restored. Automatic start-up and shutdown can improve the reliability and efficiency of the generator system. Remote monitoring and control systems are also becoming increasingly popular for generator installations. These systems allow operators to monitor the generator's performance remotely and to control the generator from a central location. Remote monitoring and control can improve the efficiency of the generator system and can reduce the need for on-site personnel. Finally, it's important to document all aspects of the generator installation, including the design, the installation procedures, the testing results, and the maintenance records. Proper documentation can help to ensure that the generator system is operated and maintained safely and reliably. In summary, ensuring compliance with the NEC and other applicable codes and standards requires a comprehensive approach that considers all aspects of the generator installation. By following best practices for design, installation, maintenance, and operation, it is possible to create safe, reliable, and efficient generator systems.